Good evening, ma'am.
Good evening.
Good evening, ma'am.
You can turn on your screens.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, everyone. Still few are left, no? Okay, let's start now. It's too much. So I hope the difference between physical and chemical changes is all clear.
Yes, ma'am.
Any doubt in physical and chemical changes?
No.
Everyone, please turn on your cameras. Come on. My screen is all black. I don't like that screen. It should be decorated with colorful and happy faces. Sriyansh, Soumya, Siddhant. So next topic is to learn more about the chemical changes in detail, because chemical changes
Like yesterday,
affect
I asked
the
you one
chemical.
doubt, like how, like based on the temperature, like change in energy or temperature. Like I actually asked you a doubt, so you told it to remind you tomorrow. So just I'm like telling you. So ma'am, like, can you clear it now?
Siddhant, tell me your query again, please.
I'm like yesterday, like in change in energy in brackets, you wrote temperature. So like I told that temperature, like when we put water to ice conversion, the temperature also changes. Like when the water was in normal temperature, then when we kept in the freezer, it was in the cold temperature. So the temperature also changed. So it's a chemical change, right?
See,
And if it's a chemical change, then it will be a reversible chemical change.
listen. We have learned that physical and chemical changes have certain factor, have certain signs to decide. Like in physical, no new substance will be formed, and mostly they can be reversed back. Okay, but we haven't mentioned that if you observe the absorption of heat or release of heat, then it will definitely be a chemical change. Means temperature involvement can be in physical also, can be in chemical also, because the water changing to ice state is just the packing of the molecules close together. And again, if we provided heat back to the same temperature, if we bring it out of refrigerator, it the molecules again, they spread apart, they get loose and changes to liquid form. So that doesn't mean it is a liquid change because the temperature changes are being observed. It's not necessary.
Okay, ma'am. Means like, can you give an example of a chemical change which is reversible?
Hmm. That is still a question. Chemical change that is reversible. I hope that
Ma'am,
with proceeding with the
yesterday
chapter,
I send you in chat.
hmm?
Yesterday I send you one in chat.
Yeah, please. Hamza, you sending or shall we proceed? Otherwise, with moving ahead with the chapter, one or the other example would definitely be no, no worries for that. Okay, let's first study about the change in energy. Just for checking, I'm not able to scroll it up and down. Hmm. So a chemical reaction is observed by the following changes. Now, first change is change in energy. Usually, energy, sometimes, like in case of photosynthesis, we require light energy, and in many other reactions, we require heat energy. Either the reaction requires heat, or sometimes the reaction will release heat after the product is formed. Okay. So almost all chemical reactions involve energy change, and some chemical reactions produce heat while some take away heat. That's a general point. So a change or the reaction in which heat is released. Sometimes the heat is released, sometimes the heat is absorbed. But when you observe that heat is released, that reaction is termed as exothermic reaction. Exo means release. and thermic means heat. Okay. For example, in a reaction between carbon and oxygen, carbon dioxide is formed with the generation of heat. That's a very simple reaction. Okay. If you can give any more examples of exothermic reaction, think about it. Take your time.
Ma'am, I have a doubt. Ma'am,
Mhm. Yeah, please tell.
ma'am, in photosynthesis, carbon dioxide is gonna be absorbed, no? So like, is it an exothermic uh reaction?
In photosynthesis, carbon dioxide is
Sorry, like oxygen is released.
oxygen is released. So is
So it
oxygen
is an reaction.
oxygen is a type of element, it's a type of gas. Is it means are the temperature and oxygen related?
But like oxygen can cause combustion, right?
Why why you are trying to connect oxygen further combustion? Combustion means burning of a substance. So is it necessary that wherever there is oxygen, it will undergo combustion? Is it necessary?
No, ma'am.
We intake oxygen. It means it starts, it undergoes combustion process inside our body.
No, ma'am.
Then,
Okay, ma'am.
see, carbon plus oxygen gives carbon dioxide plus heat. This is a very common example you can say of the combustion of fuels like CNG. Okay, because the major component in the fuels that we use, like petrol, diesel, CNG, and that LPG used for domestic purposes for cooking, they have the major element carbon present in them. So, because yes, we are burning them for our further uses. So, this reaction, carbon plus oxygen gives carbon dioxide plus heat, is the general example for the combustion of fuels. Okay, you can write in the bracket. Further, any more examples if anyone can tell? Think of it. Take your
Ma'am,
time. Hmm.
burning of a magnesium ribbon.
Correct. It gives off heat. Burning of magnesium ribbon. Great. Other students also, one of the exothermic reaction is taking place in our body as well. Any idea? If we do not intake food, if we do not respirate, do you think we'll be able to work?
No.
We
No.
will not be able to perform any task because of lack of energy. So how we are gaining energy? By respiration, by food intake, etc. So you can write either both, like digestion process and respiration also, or you can write any one, it's your choice. Okay. So these two processes also provide us energy. So it is clear from this example that this change in energy, the topic name energy doesn't mean only heat. Still, I'm telling you, it means types of heat. Okay. Oh, sorry, types of energy. Please note down the exothermic reaction definition, reaction, and examples. And one more example I told you yesterday, no? While whitewashing the walls, if we enter the room immediately, like at least for one day, we will feel suffocation and heat and like humid. Why? Because
Yes,
of
sir.
carbon dioxide gas release. So the material on the wall, the powdered form material in the wall is actually calcium oxide. When we mix it with water and paint it on the wall, it is gradually getting converted to calcium hydroxide, that is slate lime. I'm writing the reaction for that also. In respiration, See, respiration, please write the equation. Respiration is like C6H12O6, C6H12O6 plus oxygen. It gives rise to carbon dioxide plus water plus energy. Okay, and burning of magnesium ribbon.
Ma'am, this respiration formula, we have it in that respiration in organisms chapter.
Magnesium plus oxygen gives MgO for respiration. Next is for magnesium ribbon, burning of magnesium ribbon. Further combustion of fuels is already I've mentioned, and slaked lime. Calcium oxide plus water give rise to calcium hydroxide. I know these reactions, how can you remember? That's totally fine. If you can remember any two, that's fine, okay? And or you can write in just words format, no need to cram the formulas, okay? This C6H12O6 is the formula of glucose. When it meets oxygen, then we get carbon dioxide that we exhale out, plus water plus energy. So this is, third one is the reaction of formation of slaked lime. Formation of slaked lime. You can put in the bracket whitewash so that you can just remind of later on. Note these down, please.
Ma'am, CaOH, that one means calcium hydroxide. What does CaO mean?
CaO is calcium oxide.
Okay, ma'am.
That white powder that we mix with water before preparing the material for whitewash. Noted everyone, exothermic? Children noted, please confirm.
No, ma'am.
Ma'am, done. Ma'am.
Okay. Okay. Next, let's move to endothermic. This is just the inverse of exothermic. To a change of reaction in which heat is absorbed from the surrounding is called endothermic reaction. For example, carbon plus sulfur, carbon disulfide is formed with the absorption of heat. Okay, because see, these sort of elements, we know they exist, but we haven't seen them. Carbon is, we know mostly it exists in the form of a gas with other elements like carbon dioxide. And so carbon exist in coal also, like, which we call koila in Hindi. Coal form, diamond is the form of carbon only, allotrope of carbon only, and when it combines with oxygen, it becomes a gas, etc. So we haven't seen them practically. So the best example for you will be photosynthesis process, because we know it requires light energy. Okay.
Ma'am,
Mhm.
like basically the sun produces heat energy and light energy, right?
Mhm.
So like, is there any chemical reactions going on?
Yeah, that's what I'm writing actually. So
Okay.
photosynthesis process needs carbon dioxide, it needs water, it needs light energy, and further, what else it needs from the plants? Some material is very important, should be present, that is
I'm
present in the leaves
starch.
and stems. What is that?
I'm starch.
No, starch is not already present, it is made after photosynthesis. What is that? You all have learned in class grade 5 or 6. Green color substance. Other
I'm
students have
chlorophyll.
Chlorophyll.
yes.
Chlorophyll.
So on this arrow, we write the substances whose presence are mandatory. We write chlorophyll here. Chlorophyll is very necessary, and the name of process is photosynthesis. And further, can anyone tell what we get? Not in the chemical, this formula term, in simple terms.
Oxygen.
Glucose.
Glucose plus oxygen. So formula of oxygen, glucose is we have just.
C6H12O6
H2O6
This is
plus
simple to do.
O2.
That's all. Okay, so write down
yes.
this. Noted. Seventh class noted.
Yes, sir.
Hmm. Next observation in the chemical reactions are the change in color. The color of product may differ from that of reactants. Okay. before reading this example, any chemical reaction that you can tell, because a lot are striking my mind where we observe the change in color. And in our home only we observe daily, mostly in the kitchen. What do you say?
Ma'am, an apple turning brown. Like that.
Ashwarya, speak again, please.
Ma'am, an apple turning brown when it's
Yes,
cut.
yes. The rotting of fruits. Color change immediately by the attack of air, moisture, oxygen, gases, etc. So fruits are a very good example. Fruits, if they have been cut down, then they need to be consumed, because very quickly the moisture and atmosphere gases act on them and they start getting rotten. Okay, so color change. When we cook the food, we just add little spices to them, and you can like click picture before and after the food has been cooked, the vegetables are cooked, you can clearly observe the color change. Okay. Accepted rusting of iron. Any iron article that is uh, means that is old enough, so you can observe the rusting. After rusting, a brown flaky substance gets accumulated on the iron, right? That is a change in color and is a chemical change, right? So next is, for example, this we can perform in laboratory. A copper sulfate solution, this is a liquid solution which is blue in color, but after reacting it with iron, if you put iron nail into this blue solution, if you put iron blade or any substance made up of iron, after a few seconds you will observe the color will start changing to green. Okay. Children, are you getting?
Yes,
Oh, ma'am, I couldn't hear you, so can you explain it again?
Dear, change in color, the chemical reactions where we observe the change in color are rusting of iron, cooking of food, um, rotting of fruits, and the one which is shown here, that a copper sulfate solution which is blue in color, if you put any iron nail, blade, any iron article into this, few seconds later you will observe the color started changing to green. Okay.
Okay, ma'am.
Ma'am, how does it change it to green color? Copper sulfate.
See, actually, this is the reaction between, if you know that copper sulfate, in out of copper sulfate, this copper is a metal, as you must all have seen the copper wires in the uh, switchboards and many appliances. Okay, copper is a metal, whereas iron is also a metal. So in class 10, you will learn that, metals have the ability to react. And out of these two, copper and iron lies on the top of copper, means iron has more ability, iron is more reactive than copper. Okay. So if you have ever heard of the periodic table in class 10, in which the elements are arranged according to their chemical properties, that's a very big topic in grade 10. You will learn soon. So iron reacts with copper, and due to that chemical reaction, it changes the color. Okay.
Okay.
This is the reason of its color change. Next example is rusting of iron. Cooking of food. More, if you can think of more. Is it fine? Any more?
Like ripening of fruits, sometimes we can observe a color change, no?
Yeah, when the correct, correct. Yeah, very good example is that of mangoes only. No, first they appear green in color. After they have fully ripened, their color changes to orange and then yellow. Right? Ripening of fruits also you can write. Noted?
Ma'am, 1 minute.
Sorry, I have erased this part.
Oh, ma'am, can bake. Ma'am, can baking a cake can be a chemical change
Yeah.
your color?
Yeah, baking of cake is a chemical change. Yes. I hope it is done now.
Yes.
Yes, ma'am.
Evolution of gas. So some chemical changes also produces gases. Generally, the gases produced can be carbon dioxide, hydrogen, ammonia, etc. And the presence of carbon dioxide can be confirmed as it turns lime water milky. Means, how can we check? See, there is the we have the methods to check whether the gas released from any chemical reaction is carbon dioxide or hydrogen. For these two, I have the ways. Carbon dioxide, if we allow the lime water to enter, if we allow that carbon dioxide gas, whatever gas is released out from the reaction, if we allow it to pass through lime water, it will start turning milky, lime water. Okay, so it confirms that carbon dioxide is the only gas present here. For hydrogen, if we bring a matchstick near to the gas, wherever it is evolving out, it will burn with a pop sound. Okay, so these two are the ways to confirm which gas is it. Now, very great and good activity that you people can also perform. Take vinegar, all of you must be having in your kitchen, in a glass beaker, and add a pinch of baking soda that we use to cook idlis and that baking a cake also. You must be having in your kitchen. The chemical name of vinegar is acetic acid, and the chemical name of baking soda is sodium hydrogen carbonate. So they have made so many elements: sodium, hydrogen, and carbon. Okay. What will you observe? You will observe gas bubbles coming out of the beaker. This is due to the release of carbon dioxide gas only. Okay. And this can be confirmed by making the gas produced pass through freshly prepared lime water. This is just the method to confirm if it is a carbon dioxide gas only. See, I'm telling you, you people can, after this class, if you are free, it will hardly take 5 minutes to try this activity and you can capture the picture, okay, after performing. So the lime water will start turning milky when carbon dioxide is passed through it due to the formation of calcium carbonate. Is it okay? The chemical reaction is also written here. So how will you see? Means you can take the help of a straw or something. You can take any cup. Don't try to take any glass material that is transparent so that you can observe the reaction. Okay, just take vinegar in a glass beaker. It should be about half a cup is enough. Half small cup is enough. Okay, pinch of baking soda, and before adding baking soda, if you can convert it or no, I have an idea. I have a good idea how you can perform. Listen very carefully. Take a balloon. Okay, take a bottle with a narrow neck, small bottle or anything which has a narrow neck. Before fixing the balloon on this bottle neck, fill this with a half cup vinegar. Okay. Why I'm telling you to take the narrow neck bottle so that you can fix up the balloon with the help of rubber band or something. Okay. And fill this balloon with a pinch of or half a teaspoon baking soda. Now very carefully that it should not immediately get mixed with it. Try to bind and tie the rubber band with the balloon with the rubber band or some thread or whatever. Okay, you will observe that the balloon will it start inflating itself because of the carbon dioxide gas released. Okay, now after you observe the good amount of carbon dioxide has been uh, transferred to the balloon because of inflation. Take out the balloon carefully, and in another glass or beaker where you have already prepared your fresh lime water, try to bring that balloon side and try to deflate it in that fresh that lime water only. If you observe that lime water, the color changes to little bit also milky, then the carbon dioxide uh, gas released was confirmed. Got it?
Okay, ma'am.
Yes, ma'am.
Please try this activity. That's very interesting. But yeah, as mentioned here, like half cup vinegar and pinch of baking soda will be too small to inflate a balloon. So if you can take a little more, will be good. Like one small cup vinegar, small cup I'm telling, and 1 to 2 teaspoon baking soda at least, teaspoon. Okay. So I'll be waiting for your photos and videos for this activity. So do one thing, please quickly note this.
Done, ma'am.
Everyone, please note this down. And you can draw this diagram also.
Ma'am, can I leave the class? Mine is done.
Okay.
Okay, ma'am. Bye.
Fine.
Me also. Can I leave? Ma'am?
Yeah, if you have noted, you can leave.
Thank you.
Bye.
Bye, ma'am. Bye, ma'am.
Is it done?
Yes.
Should I stop sharing the screen?
Oh, ma'am, 1 minute.
Ma'am, can you give any other example for evolution of gas?
That's your homework. You need to get the examples.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Everyone, have you done?
Yes, ma'am.
Yes, ma'am.
Okay, then we'll meet in the next class. Bye-bye.
Okay, ma'am. Thank you.
Thank you, ma'am.